Okay, so we're moving on to the next unit. Now, we haven't really done anything practical with logs and all that. I mean, sometimes you're sitting there, like, is this just to kind of like retrain our brain to do stuff, or would we actually use this? And you've used logs. I know you have in Chem. I know there's a formula everyone talks about that has the log in it. You just hit the log button. You have no idea what it's doing, but you'll find out what it's doing. There's many things in science that use exponential or log form. Okay, you know, a lot of people don't even realize that the Richter scale is all based on powers of 10. Okay, a earthquake of magnitude 3 is 10 times more powerful than one of magnitude 2. Okay, so every time you go up 1, it's 10 times more, 10 times more, 10 times more. Okay, so you know, a magnitude 6 is not twice as much as a magnitude 3. Okay, it's 10 times 10 times 10 more times than magnitude 3. Sound, the decibel system, the whole pH, right? That is all based on logarithms, exponents. So you're going to use logs a lot whenever you are trying to find out how long or what is the magnitude, okay? Because the Richter scale is the exponent, okay? When it's magnitude 3.6, that's 10 to the 3.6. That's what that means, okay? And magnitude 7 means 10 to the 7th power. That's what that means, okay? And you never learn that, right? You just kind of find out that, 7, that's a lot, okay? You want to see pictures? That's what a 7 looks like. This is what a 2 looks like, okay? And you get that kind of perspective. But mathematically, a lot of people don't know the difference between the two. Now, today, I'm going to teach you a new way to do, next page, to solve exponents. So let's deal with something that is extremely easy. 4 to the x equals 12. Now, the way that we already know is I would take 4 to the x equals 12, and the easiest thing to do would be, do what? How do I find x? Same base, right? Well, yeah. Log 4 to the 12 equals x, right? And how would I put that in my calculator? Log 12 over log 4 equals x. Okay? Now, that's pretty fast. By the way, that's exact answer. Okay? Now, will your calculator get you what you're looking at right now? No. Okay? But I can verify if it's right, because I will put 4 to the x equals 12. I'll do y1, y2, get my answer. I'll put in log 12 divided by log 4. I will get the same answer. I'll get the same decimal. Okay? And when you work out the decimal, it is 1.792. Okay? That is, I've accomplished what they asked. Can you put it in log m over log n? Yep. And can you do it to 3 decimal places? Yep. It's 1.792. Okay? So here now is a new way to do these. And this way, obviously, will work as well as the one you already know. But C, the one in the already know, will not help us. You'll have to use the way that I'm going to show you. Now, the thing that you all know about exponents is the third level comes down, correct? So you can jack things up with something as long as you do it to both sides and when it's in ratio to each other. So when you have one thing equaling one thing, well, I'm going to just put this to log. Now remember, there's invisible 10 there, but I'll put it this time 4 to the x equals log 10 to the 12. Now remember, the 10's actually invisible. But do you see what I've done? I have moved both up, and by moving both up when they're logged, that third level gets to come down. So that would be x log 4 equals log 12. Now remember, there are invisible 10's there, but I'm not going to write them down. Now how would you get x by itself? Divide by log 4, right? So x equals log 12 over log 4. Same answer I got here. So you could argue that both ways are just as simple. But it sure is nice to have two ways to do it. And they're totally different ways. That's what's cool about it. One you changed right to exponential. The other one you raised them both to log 10. Totally different ways. And then you got y1, y2 on top of it, which is 3 different ways. I'm hoping, my hope for you, I hope this for every question, of course, but definitely for logs, you get to the log part and you're like, oh, good logs, okay? Like you could actually do this one 3 ways and it would take you 3 minutes. That's doing it 3 different ways, right? So logs, if you know the little rules, that's a big if, but if you know them, this is an easy unit, okay? And I promise you, if you're struggling with this unit, it's because you're missing a couple rules. Now, C is where we would run into troubles doing it the old way, okay? Because do you see that if you tried it, like which one would I make my base, first of all, but I'm still going to have x's on both sides, and one's going to be up in the exponent still. Like, it's not helping me. But what's cool is if you jack them both up, you make those x's third level. Third level automatically comes down. Okay? So this one is a lot harder question than you would think. And the amount of room they give us is the evidence of that. Okay? But there's only one way to solve this in this form. Now you're saying, yeah, that's just y1, y2 that. But how are you supposed to, from your 1.4396, how are you supposed to get that? You won't. Okay? So this is a excellent diploma question right here. Because there is no way your calculator is saving you. Now you could say, oh, I'll just put all the answers in. But what if this is a written response? Numerical response, and they want, what is M? Okay, that's all they want. What would M be? Okay, at this point, who knows? Okay, so look at this little question. And they just go, write it in the form log M over log N. Put your solution to M in the blank. Look how little that question is, and the amount of knowledge you need to do it is quite a bit. Okay? So, right away, do I know the first trick to free those x's? Move them up. Okay? So that would be log 6 3x equals log 3 2x minus 1. Okay? And if you want, if you're more comfortable, you can put the little 10's in there. But I actually choose to leave them out, just knowing if I've logged them, there's the 10's are there. But you'll get good at that from practice. Now, I have 3x log 6 equals, and you're going to have a bracket, right? Do this in brackets because it's 2x minus 1 log 3. Okay, so that's obviously the step. You'll find with logs, it's that first step. If you know the first step, the rest is usually easy after that. we want to know, hey, can you figure out the first step for this one? Can you figure out the first step's much different than the first step for that one? Okay? Now, here's the other thing that they're going to want to see is like, did you know that you have to distribute that, okay? So you have 3x log 6 equals 2x log 3 minus log 3, or minus 1 log 3 if you prefer. Now again, this is why we do this stuff in class. This is where we'd have a roadblock with some students. Okay, yeah, thanks for doing that. Now I have no idea what to do next. Well, just like we've always done, get all the x's on one side. So this would be 3x log 6 minus 2x log 3 equals negative log 3. Now, I can't subtract those two because they're both not log 6, and they're both not log 3. If that was 3x log 6 minus 2x log 6, man, am I into some easy work. Okay? But it's not that nice. And it's a good thing it's not that nice, because one thing that drove me nuts in math was the teacher always did these nice ones, and then I get to the homework, and they're not like that. They're all like, I gotta do 3 more steps, right? So you might get a nice one, but this one isn't. So if we learn how to do it this way, yep, doesn't matter. They must both be the same, the base and the next number. Okay. Now, if they were both the same base, okay, I just want to make sure, are you with me here? Make sure that if this was to the 3x, don't do this, guys, and this, I can move this up, right? I could do that. Now I could actually divide those two if I wanted, because they have the same base. Right. Okay. And that's another way to go through this one, actually, because, hey, when you actually, won't confuse you. It's a good way, though. Okay, now, but this next step, again, not intuitive. But once you see it once, you'll be like, oh, yeah, okay, that's what I would have done. But remember what the goal always is? Get x by itself. And you see how they both have an x? So take x out, factor it out. 3 log 6 minus 2 log 3 equals negative log 3. See, that makes sense, right? And then, how would you get x by itself now? You divide that out, right? So what if I do divide out 3 log 6 minus 2 log 3? Do you see it's gone on the other side? It would be x equals negative log 3 over 3 log 6 minus 2 log 3. That makes sense? Now, do you see how far we're away from log m over log n? Okay? We still can't answer this question. At this point, what would you try? Yep. You can't do that because there's a subtraction sign in between. If that was a multiplication sign, you could. Okay? Good question. I'll bet you that answer's there for you in the multiple choice. Come on, you guys. We can do this. Yep. Okay. So we'll move this here, and we'll move this here, correct? So then I would have, okay, we're not going to do D, so you got all that real estate there. This would be y equals negative log 3, x equals negative log 3 over log, what is 6 to the 3? And log 2 to the 3. Okay? Could I do this? Log 6 to the 3 over 2 to the 3. Am I allowed to do that? Who can tell me why I'm allowed to do that? Yeah? When you subtract logs, you can divide. That's what I have. Yep. There's tens here, right? There's little tens there. Invisible 10. So I use the rule that you can, when you're subtracting with the same bases, you can divide. So 6 to the 3 divided by 3 to the 2 is 24. So I have x equals negative log 3 over log 24. Now, really, do I have it in log m over log n? No, I don't. See? Mean question. But you guys, every unit will have one mean question. It is so weird how the diploma works. But all we do is try to get you to learn these questions. The better you do, the more they sit down and they make it harder. Okay? So if you look at people that, I mean, they used to actually use teachers to help write diploma questions. So the diploma questions, like for Chem, this happened. This Reardon was making questions to make the diploma harder, and then coming back to his exact classroom and trying to get them to do better on the diploma. Right? It's very like, you know, obviously, what do you do, right? So this one would definitely, like there would be people that would put 3, like if it said log m, write m down to the nearest tenth. That's it in your numerical response. So many people would put 3 at this point. But it's not allowed. So that's the same thing as x equals log 3 to the negative 1 over log 24, which would equal log 1 over 3 over log 24. So your answer might be 0.33. Okay? Now again, it's a great question to teach with. And it's a great question that I don't think you'd ever see anything harder or trickier. But this one has, look at the amount of room it took to do this one. Look at the question. That's all the question was. Get it into log m over log n. Okay. Okay, let's go to example 4. This one here says, let's do it as an exact value, okay? You guys, if you ever see anything in a question that says to 3 decimal places, do not solve it the long way. Y1, Y2 it, okay? If that was the only way, I'd say don't do that, okay? But you're going to come after and you're going to do it the long way. You have to get that diploma finished. That's your first goal. Get it done. Then you come back and you polish it up, okay? But you have to get it done. So if I see the 3 decimal places, this is a numerical response. Y1, Y2 this. You probably have a 95% chance of getting it right. The only reason you got it wrong is because you put it in your calculator wrong. You typed the wrong number. So even if I was doing this one, Y1, Y2, I would do it 3 times, probably, to make sure I got the same answer 3 times. Write it down, move on to the next one. Okay? Later I would come and I would do it the long way. So here is the way that I would do it for exact value. For 3 decimal places, I would Y1, Y2. Okay? For exact value, this is the way I would do it. The first thing I would do is I like to get it so something equals something. So you can minus the 9 right away. So you have 7e to the negative 2x equals 12. 3, I mean. Okay? That's not a bad little question. How bad can this be? What would we do next? Change it to log form. That's exactly what they would want you to do next. Double log. Oh, you want to raise it up? Yeah, you could do that. I wouldn't do that yet, though. No. Whenever I go and change it from exponential to log, I should have a power, one power by itself. Do we have that right now? Do I have that power by itself? No, the negative has nothing to do with it. Can anyone tell me what the power is? That's the exponent. What is the power? It is e to the negative 2x. That's the power. Okay? So what am I asking? What's the power? Okay, if I said, what is 5e to this, or like, well, I don't have to use e, right? I'll use x to the 6. Does that 5 have anything to do with the 6? So what's the power? X to the 6. That's 5 times the power. Okay? This, what would be the power? 5x to the 6. These are very, very different. Okay? You treat them very differently. So what should I do next? I want to get the power all by itself. Okay? So this is a big concept. Because if you did it with the 7e together, I promise you there will be an answer in the multiple choice waiting for you. Okay? But hopefully you're going to graph this, you're going to graph the answer that you got, and you're not going to get the same picture, and you're going to go, okay, I did something wrong. Okay? Now, we will change it to, well, there's two ways to do this one. Why don't we get creative and raise it up? Now, you could be very deliberate here. Okay, let's get off our phones. Okay. Instead of just putting it to log 10, if I like, I can put it to, I'm going to do this in blue, log e to both sides. Okay? Why is that so convenient for me? That just means I got negative 2x equals log e 3 over 7. Yep. Now, I can do, as long as I do it to both sides, I could have done log 10 to both sides, but I like to make life as easy as possible for myself, so I'm going to do a step that will do that. Okay? Now, very easy, to get this to x equals, I'm just going to divide by negative 2. And most likely, you will see this as negative 1/2 log e to the 3 over 7. Who can tell me probably the most probable way they would have the answer in the diploma? Because they want to see if you know one more rule. If you left it like this on a written response, for me, I'd give it to you, right? But if it's a multiple choice, they want one more. Do you know one more rule? And the actual answer would be 1/2 log e to the 7/3. You get why? Huh? Who can tell me what happened? This was brought up here to the -1. It's another rule they'll just build in, right? And you're going to get negative. Like if I gave this one in the homework today and it came out as -1/2 log 3, why are they getting 7/3? Like what have I done wrong that they're getting 7/3? Oh, they just brought their negative up. Makes it -1. Okay? So it actually incorporates another rule. Like I have some students that are just like they're finishing that quiz in about a minute. They're looking around, right? They just know their rules, right? I have some students still do not know their rules. So this is where my spectrum lies, okay? If you know your rules, these are very, very easy. If you don't, they are hard to impossible and very frustrating on top of that, okay? Now, the next thing is, did you guys know that you can solve these by using y1, y2 in your calculator? Okay, that's what this next part is about. We've done that to death, okay? So I'm not going to give you notes on how to do y1, y2. We have done it many times. So we're doing 1ac, 3ac, 5, 6, 7b, and 10 to 15. 1ac, 3ac, 5, 6, 7b, and 10 to 15. So you probably heard the nasty rumor that you're doing 2 lessons today. Usually I would say don't believe in rumors. Today they are accurate. Okay, so we're going to the next one. I'm just scrolling through the homework for anybody at home. Forgot their textbook in their locker. Okay, so let's do probably the most basic need for all this logs and powers and everything. It's to deal with compound interest. Compound interest is one of the most common need for solving for n. Okay, and n is usually, well, when it comes to money, it's time, and time is obviously something that needs to be calculated quite a bit when you're looking for it. Hey, how long does it take to double? Okay? Now, you guys have done this to death, I'm sure, simple interest and compound interest, right? Simple interest means basically, you know, if you borrow $100, I'm going to charge you interest on $100 for the next 5 years. Okay? The good thing about that is that you are not getting charged for the interest on top of your interest, okay? But if you're making payments on something, like, hey, I'm making $1,000 a year payments, well, at least after 1 year, you'd only be having to pay interest on $4,000 if you gave 5, right? And then next is 3,000. Like when you're paying off your mortgage, you actually, you know, at the end of a year, you're getting charged only on what's left. Okay? But what a lot of people don't know is how compound interest really works. Okay? Like if you bought a house, pretty well any house, let's say a $500,000 house though, and you had a mortgage for 25 years, and say you're making payments $1,200 a month or whatever, that would be your minimum payment. Your minimum payment, roughly, it's very close, your minimum payment will allow you to pay twice as much for that home when you are done. So after 25 years, if you calculated how much money you gave your bank, it'd be about $1 million. Okay? So if you pay your house over, and they even have now, because when the house prices went up so high, they were giving out 35-year mortgages. So you were actually paying more than double your house value when you were done. Okay? So the thing is, well, I'm not going to get a mortgage. There's not a lot of people that can come, just from any place and have $500,000 and buy a house. Okay? Uh, so there's kind of two things in life that you almost have to go in debt for. Okay? First one is your education. Okay? There's a debt that I'm saying, you know what? It's going to be a great investment, right? It takes money to make money, so you're going to have to go into debt. Most of you will have to go into debt for education. Okay? Like when I got out of university, my debt was $40,000. But because of the awesome government that we have and the whole thing and some of the marks I got, well, that's how much they gave me, was $40,000. And I think what I had to pay back was 10 through grants and this and Rutherford scholarship, blah blah. Oh, no, that's on top. I got 40,000 on top of Rutherford scholarship. So that's, hey, but you know what? I had no other. I paid for it all myself. I didn't have my parents helping me, whatever. So it's either don't get a loan and don't go to university, or that was my only two options, right? And a home. I mean, it's hard just to come out and say, hey, awesome, I love this home. Here's 500,000, man. Right on. It's done. Okay? Like you can buy a car without a debt. Very easy. Okay? But education and home, very hard. Okay? And both of those I would recommend. Obviously homes are nice, right? Keep us warm, right? You can store food in them and stuff. Okay? And obviously, I believe highly in education. So going into debt for that, again, awesome investment. In fact, that investment sometimes, I think most students are able to have their loan paid back in about 5 years. Okay? Not horrible. So, when you graduate, I mean, I think when I graduated from university, that was the poorest I've ever been in my entire life. Okay? No money, $40,000 in debt. You just kind of, okay, yeah, sure hope I get a job. That would be awesome. Okay? And I was very lucky that I was actually able to get a job before I even graduated. I had papers signed, everything. I had one more exam to write, right? And then I was on to a job, right? So it was good. That's kind of how I try to move my life, because I'd be too stressed out if I actually had to now go find a job after I had all that debt and everything. So let's find out about how all this debt goes, okay? Because that's, the David Chilton, I mean, the amount of money, I wish I had the figure, but consumer debt, it does not include your home. And Canadians are hugely into debt on consumer goods, right? Credit cards maxed out. Like the average Canadian is, I don't know how many, a few $1,000s in debt. Okay? So banks love you if you're in debt. Okay? You are their best friends if you're in debt. Now, if you're not paying your debt back, they're not your best friends. But if you are making your payments on your credit card, you're making payments on your car, you're making payments on your TV, on your couch, on your home, you can finance anything you want. Okay? You can even finance food, right? You buy it on your credit card. You're paying like 6% interest on it. As soon as the month ends, you're paying interest on your bread, on your oranges. Okay? And if you think that's funny, it would be impossible for you to probably pass 3 people anywhere, and probably two of them, at least probably two and a half of them are in debt. Okay? So it is probably, if you can stay out of debt, you will be a huge, huge minority in Canada, but you'll be an extremely happy person. Okay? People that are not in debt are very happy people. Okay? Because stuff makes you very unhappy after you get the bill. Now, let's skip right to the compound interest formula, which is a couple pages away here. Okay. So the compound interest formula is A equals P1 plus I to the n. Now, do you see how logs are going to come in handy whenever we need to find that n? Okay? And n is obviously a valid piece of information because that's number of years. Okay? But we need to talk about a few things, and that's this chart. I'm just going to use this one example to help do this one chart, because look at the compounding periods on the side. They're all different. We have to know how to deal with them. So if you had $1,000 invested for 5 years at an annual rate, interest rate of 6%, interest will always be given at an annual rate. Okay? So you will see this throughout the curriculum. Okay? It says complete the table and calculate the final amount of the investment if the interest is compounded according to the period of the time given. Okay? Now, I want to just talk about for 1 year. Okay? Here's 1 year. How many compounding periods would there be if we went annually? How many annual periods are there in 1 year? 1. Okay? Now, what about semi-annually? There would be 2, would there not? How about quarterly? 4. How many months in a quarter? 4 or 3? Common answer is 4. It's wrong, but that's a very common answer. Okay? Because they're like, well, 1 quarter, so 4. No, but how many months? Okay. And monthly? 12. How many days in a year? 365 and a quarter. Right? That's why we have leap years every 4 years. Okay. Now, how many compounding periods in 5 years? How many annual compounding periods are there in 5 years? 5. How about semi-annually, how many compounding periods would there be in 5 years? 10. How about quarterly? How about monthly? Can anybody give me a way to be able to, a formula to get those numbers? How did we get 10, 20, and 60? What'd you do in your head? Okay, if you take this and multiply by 5, okay, this is important for you to see this, that, well, actually I'm going to show you in the formula when we do that. Now, interest rate per compounding period. Interest rate, all you always do is you take your annual interest rate and divide by your compounding periods. So you would go 0.06 divided by 1. This would be 0.06 divided by 2, which is 0.03. This one would be 0.06 over 4, which is 0.015. And 0.06 divided by 12 equaled 0.005. Now, the book does it a bit different when they find out their formulas. They like to use all their calculated numbers and just put them in. What I'm going to show you is the way that I want you to do it, so it helps you do, there's a place where you can check that everything is right. Okay? So if I was to find out how much money I'm going to have, my formula for annual would be this. A equals 5,000, or sorry, 1,000, what are we talking about? 1,000 times 1 plus 0.06 over 1 times 1 times 1. And that would be, sorry, 5 times 1. Sorry, 5 times 1. And then I always check this to make sure they're the same. Okay? And you get 1,338 and 23 cents. Okay? So all we have to do is stay consistent with those two loops all the time. So the next one would be A equals 10,000 or 1,000 times 1 plus 0.06 over 2 to the 5 times 2. Again, make sure you have that check in. And you'll get 1,343.92. Now, in the same amount of time, you made $5 more. Okay? So is it worth maybe driving across town because that one does it semi-annually? Well, it's going to cost me like $15 to drive on the other side of the city and back, so for $1,000 I'm not going to do it. But you can see how $1 million, it's a bigger deal. Okay? Now, there was a guy that he had a program put into the computers at his bank, and say your interest came out to, like you got $12.953. That's how much you got. Now the bank will actually only give you $12.95. Now there is probably no one that would worry about that 0.03 of a cent, or 0.3 of a cent. Okay, 0.3 of a cent. But what this guy had done is he had programmed the computers, or basically put a virus in the computers, that all those 0.03s, 2s, 5s, 8s, and 9s went into his bank account. And it was very clever because now none of the employees noticed, none of the accountants noticed, none of the people noticed, because they weren't complaining over 0.3 of a cent, $0.003, right? So it was a long time before he got caught. Okay? And the thing is, if he would have stopped it, like he made millions, because the bank has so many customers, right? He made millions off that because it adds up. So think about $5. If the bank, says, well, let's not do it semi-annually, we'll do it annually. Look how much less the bank has to give you for your money, right? And when you're shopping for a mortgage, or you're getting any loan, check out if it's monthly. Some are monthly interest, some are daily interest savings accounts. Okay, obviously the interest rate doesn't matter all the time, but how are they compounding it? Okay, So quarterly would be A equals 1,000 times 1 plus 0.06 over 4 to the 5 times 4. Okay, and without giving the answer because we're getting low on time, I'll just 1 plus for monthly 0.06 over 12 times 5 times 12. Again, making sure the 12s are there. Okay, so instead of going through and doing the math for this one, this is like the easiest question you'll ever get. 7,000 invested for 6-year GSC compounded quarterly at a rate of 5% per annum. Determine the value of the investment at the end. So A equals P times 1 plus I to the N. So what don't we know? A, investment at the end. So A equals 7,000 is put in. This would be 1 plus 0.05 over 4 to the 6 times 4. 6 years. Okay, does that make sense? Quarterly. That's a good question, actually. Okay, so circle the quarter and put the 4 there. Okay? And just for your own purposes, 9431.46. Okay, let's get to, there's two other ones that aren't as clear cut, so let's get to them quick. So we're just going to do example 4 and 5. Okay, example 4, we're investing 25, or Christine is, 2,500 for 4 years, compounded semi-annually, and she receives $843.26 in interest. What was her annual rate of interest? Okay. Now, right, how much money does she have now in her hands at the end of 4 years? How much? Right. We need to add these two together. Obviously, the mistake would be putting that as the A. That's where they want to catch you. Okay? So we need to, because that's how much money I have now at the end. So you got to make sure you add these two together for your A. Okay, so that's one thing, one trick that they could catch you on. So you're going to get $3,343.46 equals, you started with 2,500. Oh yeah. Yeah, it does. It's 20 cents. Okay. I just gave you guys extra money. Is 2,500 1 plus? Talk to me. How much? I over 2. Very good. Okay. The book doesn't do it this way. They like to actually do it at the end where you really have, it's confusing at the end. So I put it just like we learned it. And then what would I put up for my exponent? 4 times 2. Again, checking that that's the same. Okay. Now what would be the next process in solving this? Got to divide it out, right? Because you can't do anything, you can't get that I exposed until you get the 2,500. So we won't even calculate it. We'll go like this, 0.26 over 2,500. We'll leave it as a fraction. Equals 1 plus I over 2 to the 8. Now how am I supposed to get I out of there? The 8th root or to the exponent 1/8, right? Now you can actually put that into your calculator and you will get, now always put your exponent in brackets, right? Always put that in brackets. And you will get 1.037 equals 1 plus I over 2. So now we would subtract 1, correct? Okay, just coming up here. So that is 0.037 equals I over 2. Times 2 to both sides. Yep. Okay, so you will get 0.074 equals I. So interest is 7.4%. Okay, let's do one more. Barbara invests $8,000 in account, which pays compound interest 6%, compounded monthly. How long would it take in years and months for her investment to double in value? Okay, let's say 16,000. How'd you get that? Doesn't say 16,000 anywhere. Double. Okay, so double in value. So $16,000 equals 8,000 times 1 plus 0.06 over 4 to 12 right? Exponent would be n times 12. Make sure and do this, okay? It is a subtle little check, but you have to make sure you do that check, or I think I'm going to have students getting it wrong, okay? Now, the next calculation is very easy. Divide it out, and you will get 2. Whenever you get double, you're going to get 2, okay? And then 1 plus, in brackets, 0.06 over, actually, if you want, that is, you can calculate that, which is 0.005 to the 12n, which is 1.005, right? Now it gets to something where you're going, okay, yeah, I could deal with that. Well, how would you deal with that? Can't, because it's held captive. You take a log. Remember that log thing we learned a long time ago? Oh, actually today? Okay. Change the log form. What's the base? Right. So 12n equals log 1.0052. Okay? So really, now I can make n equal log 1.0052 all divided by 12. Okay? Everyone put it in so I can ask somebody what the answer is. Okay? Emily, what'd you get? Don't round for me. 11.581 Okay? Now, it asked it for years and months. So that's 11 years and 0.58 years, right? Which isn't months. So this would be 11 years. How do you find months? Multiply by 12. What do you get? No, I don't want total months. I want 11 years and this many months. 6.96. Now, 6.96 months, would it double? No. 7 months. Okay? So that would be 11 years, 7 months. Okay? Or, like we heard, okay, it can be also 139 months, right? Total months. Yeah. So let's get this in our notes. Just circle this and go multiply by 12. Because it's like when I say 0.2 of a year, huh? What do you mean 0.2 of a year? How many months is that? Just take 0.2 times 12, okay? Okay, so is there any new calculations? No. Okay, it's getting the formula set up so you can just do your log rules and stuff. So we're doing 5, 7, 8, 10, and 11. Who marks your exams, by the way? Oh. You wished I would mark the big one.